Greetings out there in YouTube land. Rusty and I are starting now on our second 100 videos, and we thought it might be an interesting topic to just have sort of a general overview of speakers, how they're made and how they function. So if that sounds interesting, grab a beer and pull up a chair and let's get started. Hey Rusty, are you going to take some time out from chewing on that nasty old rawhide bone to help me with this video? Huh? Don't ignore me, Rusty. Well, on second thought, ignore me. What an obedient dog. I hope that everyone's aware of the fact that wattage refers to the amount of heat that an electrical component can tolerate. In this case, this resistor can tolerate 5 watts of heat. It will radiate heat away from itself, and as long as you don't run too much current through it to go above 5 watts, it should last a long time. 10-watt resistor has to be much larger to accomplish this. 25 watt is about 2.5 times the mass of the 10 watt, and then we go up here to the big 100 watt resistor. Now in speakers, what determines the wattage of the speaker is the voice coil. All of the music signal is going to be sent through this puny little wire coil within the speaker. Sometimes 3, 4, 5 amps of current will flow through this, depending on the power of the amplifier and how high you have it turned up. So the limiting factor is how much current can flow through this voice coil before it overheats, melts, and becomes open. Now you can get an idea of the wattage of a speaker by looking at the size of the voice coil. In this case, this one is probably around 3/4 of an inch in diameter. This is a really puny one, probably from a radio speaker, and it might be able to handle 1 or 2 watts. Okay, then we will step up here to a medium-sized voice coil, which could probably handle 20, 25 watts of heat dissipation. In this case, now look how much larger this is than the previous one. This one will probably handle up to 50 watts, like this one will. Okay, so as we look at this one's probably around 30. And one other thing you can do to enhance the power handling capability of the voice coil is, if you notice, these are wound around like a cardboard or paper form, whereas the modern voice coils are wound around either mylar, aluminum, or in some cases even titanium, so that the metal here will help dissipate the heat. It's like a radiator in a car. It will take the heat away from the coil and allow it to dissipate into space, and greatly increase the power handling capability of the voice coil. Now this is where most speaker damage occurs. Somebody may hook up a 25 watt 12-inch speaker to a 50 watt amplifier and then run it at nearly full volume for a while, and pretty soon you'll notice that everything gets real quiet because the music signal is coursing through here, several amps of music signal. The coil is going to overheat, and these tiny little fine wires that are not much bigger than human hairs, if they are as big, will overheat and melt, and you'll get open places in the coil, which then destroy the speaker's ability to conduct the signal through it, and the speaker will cease to work. So it's always a good idea when you're going to buy a used speaker, take along your ohm meter and check for the resistance of the voice coil. You should get a reading on an 8 ohm speaker like this. You should get a reading of around 6.8 ohms of resistance in the voice coil. The reason it's not 8 ohms, when we know it's an 8 ohm voice coil, is that the nature of the coil is it's an inductor, and because of that it has added resistance to the passage of alternating current. In other words, we measure this thing with no signal going through it and we might get 6.8 ohms. But when we send an alternating current like the music signal through the coil, it has added resistance to the alternating current that you're trying to put through. And it will add another 1.2 ohms or so to the 6.8, so that when the speaker is actually functioning, with a music signal coming through it, it will have what amounts to 8 ohms of total impedance. Another even simpler way is carry along a battery and a couple wires and hook it up across the terminals. Listen. If you get any noise out of the speaker, odds are the voice coil is in good shape. So now, using this old beat up speaker over here, let's see how the polarity of the music signal affects the cone's movement. Let's hook up the battery. Here I just got a little 1.5 volt battery, and I'm going to hold the wires here, and let's watch the cone. Notice when I give it a positive input, the cone comes forward. So that's what's going to happen when this part of the music signal arrives at the speaker. Now let's reverse the polarity of the battery and watch what happens to the cone. It goes inward, moves in the opposite direction. That would be down here to coincide with the negative part of the music signal wave. So now, when you recall that the music signal is changing polarity 500 times a second, 1,000, depending on the frequency of the note that was struck, say on the guitar, the cone is going to move at exactly the same frequency. So if you give it a 1,000 cycle per second input tone, the speaker then will vibrate back and forth at 1,000 cycles per second, and you will hear the frequency that you put in to the speaker. Now, because the voice coil is going to be moving back and forth within a very tight space that exists between the pole piece and the upper pole plate, we want to make sure that dirt and grime don't get in there in that little narrow passage and cause that kind of scratchy sound that I imagine some of you heard from older speakers. So we're going to put in almost like an air cleaner in a car. Okay, it's a fibrous dust cover here that's going to keep the dirt and particles out of that gap. Here's a brand new one here that hasn't been installed yet, and you can see it's corrugated, and that allows the speaker cone to move back and forth, and it has a little tiny bit of porosity to allow air to get through, but hopefully not any kind of dirt or grime. Here's a small one, and sometimes these are referred to as spiders, and if you've ever wondered why, because it doesn't look like a spider, well, look at this. This is from an old radio speaker, and look at how the voice coil was suspended. Okay, instead of a fibrous dust cover like this, they used what amounts to like cardboard almost, and it looks like a spider, doesn't it? So you'll see where these old names are applied to things like B+ for the high voltage in an amplifier and spider for the dust cap. This is where they come from. Now I have a cautionary tale to share with you regarding this really nice old vintage speaker. It's the 2's not real visible. A 220 is a Jensen, made in the 8th week of 1968, and it is a C12Q. This is a very desirable, just about mint vintage speaker with a flawless cone. But sadly, whoever owned it before me ran it at way too high a wattage for way too long and burned out the voice coil. Now here's the voice coil from this speaker. It's a 1¼ inch voice coil for a 35 watt speaker, and right here I think you can see the burned area. Either the voice coil arced across itself or it arced to the pole plate. But either way, it has lost continuity, so the signal from the amplifier could not get through it. Speaker was ruined. Now normally you would just throw this in the dumpster, okay? But because of its age and rarity and value, I decided to try a heroic repair, and I surgically removed the voice coil from the center here of the cone. And what I will do next is get a 1¼ inch 8 ohm voice coil, shim it in here so that it is centrally positioned between the pole piece and the pole plate in that narrow gap, and then I will epoxy it to both the dust cover down here and to the cone. Then I will put the original dust cap in, and I don't know if it would be even possible to tell that the speaker had been repaired. But all of that would not have been necessary if this speaker had not been run at a much higher wattage than it was intended for. Another thing that's kind of interesting is to connect the moving speaker cone to the terminals on the speaker basket. You have to have something flexible, okay, because that speaker cone is going to be moving all around. So we use a weird kind of connection here. It's a silk thread that has silver wrapped around it, kind of like silver fibers, so that we have a really highly conductive wire is what it amounts to, but it's also very flexible and can flex like 98 million times without actually breaking. If you hooked up a single filament wire between the cone and the terminals, I think it'd work just great for about, what, 10 seconds? And then all that flexing would break the wire away from one end or the other, and the speaker would be no good. Okay, next let's dissect the speaker and see how it works. I started doing this like a lot of you when I was about 5 years old, and I wondered how my wristwatch worked, and much to my parents' horror and chagrin, I found out. It was only much later that I figured out how to put things back together. Anyway, let's dissect this speaker. First of all, let's look here. We got this foam surround. Right off the bat, this tells you this is not a guitar speaker. Okay, guitar speakers tend to operate in open back cabinets, and they have a much solider suspension, a much stiffer cone excursion. This is a hi-fi or stereo speaker, and they put this foam perimeter suspension material in here, and then put this in a sealed cabinet where the air behind the speaker cone will restrict its movement and, sort of like a governor, keep it from just thrashing too hard and fast and self-destructing. You put this speaker into an open back cabinet and it will tear itself to pieces just like this one did. Okay, first remove this little dust cover. Then we take a look in here, and you can see this has the mylar or aluminum style of voice coil form. Okay, and you can see where it's been epoxied into the cone, and also rather crudely epoxied the connections between the voice coil. There's two tiny little wires that come up here and that wrap around the silk threads that connect, as I showed you, the cone with the terminals. Next, let's remove the speaker baffle gasket. Okay, it's nice if you can remove it intact if you're going to recone the speaker so that you can reuse it. You see how thick it is, and that's what fills in the gap between the speaker basket and the baffle of the speaker cabinet. Now, one real bush league mistake is when you're attaching the speaker to the cabinet, over tightening the screws. If you over tighten the screws, this metal is fairly thin, and if you warp or in any way deform the speaker basket, you're liable to end up with your voice coil rubbing on the pole piece, and you're going to end up with a scratchy speaker that doesn't work well. So use lock washers and just tighten just where it's kind of firm but not over tight. Be sure if you ever pull out a speaker and see that it's been deformed by over tightening, be sure you check to see if the voice coil is still freely moving. And a lot of times they aren't. Okay, I unsoldered the little flexible silk and silver connectors down here, and I cut around the dust cover, and now we can just lift what's left of the cone out of the speaker. As you can see, nice voice coil in really good shape. Nothing wrong with this voice coil. The only thing wrong with this speaker was that it was a hi-fi speaker and it had that foam perimeter suspension material. Beautiful voice coil. Okay, let's look down inside, and you'll see the narrow little passage that the voice coil actually goes down into and then is vibrating back and forth within this narrow passage. And this is why sometimes if you have a speaker that makes a rubbing sound or a scratchy sound, there's probably something down in here between the voice coil and either the pole piece here or the pole plate out here, and it's rubbing and scratching as it goes back and forth. Okay, so that's the inside of the speaker basket, the inside of the terminals where that silk and silver flexible connecting wire came over here and was soldered to. And by having the magnetic field of the ceramic magnet expressed both through the pole piece and the pole plate, you have its magnetic field on both sides of the voice coil, and therefore able to exert the maximum possible control over its movement either outward or inward. Now let's take a look at the magnet. Also, you can see this is the magnet here, and here is the upper pole plate, lower pole plate, and the pole piece is connected to this pole plate. It's like a sandwich here where the magnet is the turkey, okay? And the magnet has a hole in the center. This magnet, it's sort of like an inner tube or a lifesaver, and the pole piece that's connected here to the pole plate will protrude through it and come out right up here. Now, the size of the magnet and the type of the magnet are important for the tone of the speaker. This is a ceramic magnet. Ceramic magnets look like a big can of tuna fish, okay? It's a good size magnet. Some of them are smaller, some of them are larger, and the general rule of thumb is the larger the magnet, the better control you will have over the speaker cone. You could probably hit lower lows if you have a larger magnet. So I would expect bass speakers to have good size magnets, and little puny speakers like mid-range or tweeters not to have very large magnets at all. So the other alternative besides the ceramic magnet is something we've all heard of called an Alnico magnet, and it's kind of easy to tell the difference. Now, Alnico magnets are much smaller, okay, much more expensive, and the Alnico stands for aluminum, nickel, and cobalt, and they usually have this little rectangular housing over the magnet. So if you see a speaker with a magnet like this is an Alnico speaker, okay, and this one back here is the cheaper and much more common ceramic type of magnet. Now, whether you have a ceramic magnet or an Alnico magnet in your speaker, it's important that you remember that you have a permanent magnet speaker. Okay, by that I mean that with no electricity connected to this speaker, it still has a strong magnetic field, both the Alnico and the ceramic. These are permanently magnetized. Now, there's a whole different family of speakers that we will discuss in a few minutes that do not have permanent magnets. Now it's time to discuss a much less understood type of speaker. It's called an electrodynamic speaker, and judging from some of the comments and inquiries I get, there's a lot of people who aren't really certain about these things. So let's clear that up. First of all, electrodynamic speakers are generally used in much older amplifiers. So today we're going to take a look at a really nice old 1940 National Dobro amplifier and pull out this lower compartment, and we're going to take a look at the speaker that was included in this amplifier back in 1940. And here we look at a 12-inch National Dobro speaker, and we see that over here we have the output transformer, which in these early amplifiers was generally either screwed or riveted to the speaker basket. Now, this looks sort of like an Alnico magnet speaker, doesn't it? It's got that rectangular housing with airspace and then a sort of a smaller circular magnet. But it's not an Alnico speaker. If you look real close, that is a giant coil of copper wire that wraps around the pole piece. Now, this is called a field coil. It's probably 1,000 or 1,500 ohms of impedance, and these two wires here are going to connect with the amp chassis. This field coil has an added feature that's pretty interesting. Now, this speaker also has one other feature that's sort of amusing, and that is this really narrow, sort of thin coil that's tacked on the back of the field coil and has its own two separate wires here that energize it. This is a humbucker coil. And now, for those of you who thought that this type of humbucker technology originated with guitar pickups, I hate to break your heart, but they knew about the concept of having a coil wound opposite to another coil around a magnet, in which the opposite winding of this one would neutralize the hum generated by this winding. So all they did to make humbucker pickups was wrap this around a much smaller diameter magnet, do it 6 times, and put it on a guitar. So this is the humbucker coil back here to neutralize any hum that might originate from the field of the large field coil. Now, these were the first speakers with field coils like this. Then, because big spools of copper wire are very expensive, they decided to go with Alnico magnets inside, and as you can see, it's just a small step when you're building this speaker to remove the big field coil copper spool and put in an Alnico magnet, slide it down on the pole piece, and then you have what we've all been looking at for years in guitar speakers, an Alnico speaker. Now, why they did this is the Alnico magnet at that time was much cheaper than a spool of wire. Then they found that ceramic magnets were much cheaper than Alnico magnets, so they went that route. Okay, so we've really had 3 different types of magnet used on the rear of these speakers. First, the electromagnet, and then second, the Alnico permanent magnet, and then finally the ceramic permanent magnet. Now let's take a look at a schematic to see how the field coil is energized and turned into an electromagnet, and to see how it serves a second very important purpose as a filter choke for the amplifier power supply. Now let's take a look at a schematic for a Gibson EH150, about a 1937 amp that uses an electrodynamic speaker. Let's look here. Here comes our B+ out of the rectifier. It passes over one electrolytic capacitor to eliminate ripple, and then it goes right through the speaker field. There's no carbon resistor here like in the less expensive or later amps, but the giant, in this case 750 ohm speaker field coil, which is not only being energized and turned into an electromagnet by this current, but is also serving as a filter choke for the power supply and getting rid of a whole bunch of ripple. Well, now we've covered the evolution of the audio speaker. Starting out with the electrodynamic speaker back in the 30s and 40s, which used a large field coil that was both an electromagnet and a filter choke for the power supply of the amplifier. Then we saw that due to economic considerations, they changed to an Alnico magnet speaker, okay, back in around the 50s, maybe early to mid 60s. Now they still make them, but as you all know, they're very expensive. Then finally, the Alnico speaker gave way to the much less expensive ceramic speaker, which is by far the most common found in guitar amplifiers today. Well, that about does it for today's video featuring the design and function of speakers. We really appreciate the time you take watching our videos and leaving hopefully favorable comments. And we just want to say thanks so much, and we hope to see you again in the near future. Bye for now.